Hi class, today we're going to talk about modern classification. We already covered the early classification systems with Linnaeus and Aristotle. We talked about the domains, the kingdoms, the phylums, all the way down to species. All right, so our essential questions of today: what are the similarities and differences between species concepts? What are the methods used to reveal phylogeny, and how is a cladogram constructed? Let's review our vocabulary. We have evolution. That's just change in allele frequency over time. Our new vocabulary: phylogeny, or phylology, character, molecular clock, cladistics, and cladogram. So first, let's talk about the topological species concept. This is what Aristotle and Linnaeus used. They took the different characteristics, physical characteristics of species, and looked at the similarities and differences and broke them up into categories. For this to work, species needed to be unchanging, distinct, and they had natural divisions between them. We know that this isn't the case. Species are changing over time. The concept that we talk about mostly is biological species concept. That's where you have a species. They're considered a species because they can mate and reproduce successfully together. If they cannot reproduce and have viable offspring, they're no longer the same species. This works well for living, sexually reproducing organisms, but it doesn't work for extinct organisms or organisms that reproduce asexually. So for those, we'll use phylogenetic species concept. Phylogeny is an evolutionary history of a species. So we're going to look at where it breaks off with other species, the different derived characteristics, what ancestral characteristics it has. All of that will be taken into consideration on its location on a cladogram or on the tree of life. Okay, so we've got different characters. The characters, they can be morphological, so physical, or they can be biochemical. That's going to be our DNA, RNA, amino acids, all of that stuff. Okay? These are characteristics that are going to be inherited from a common ancestor and is common between species. So let's look at our morphological characters. Let's look at birds and dinosaurs. They don't look the same, but they do have morphological characteristics that are the same. Both of them have hollow bones, and that shows that they're closely related. So they're more closely related than, say, other species. Biochemical characteristics. As I said before, these are our nucleotides, our amino acids. We see here we have our chimpanzees, our gorillas, our orangutans, and we're looking at one chromosome here, and you can look and see there's so many similarities. The banding is matching up very well. Not exactly, but very well between them. From looking at this, I could probably say that orangutans are more closely related to gorillas than they are to chimpanzees. Molecular clock. This is going to take into consideration each of the changes, the biochemical changes that happens. It's going to track it all. It can be kind of hard to read a molecular clock because the rate of mutation isn't consistent. We'll talk more about that when I come back to class. All right, cladistics. This is going to show how and where each species divides off from their common ancestor. We're going to look at two types of characters. They're going to be ancestral and derived. We've talked about these before. Ancestrals are passed from generation to generation, species to species, and derived are going to be new, and they're going to be found after a branching off point. So let's look at a cladogram. Here we have our cladogram. Each species that comes off is going to be called a clade. Each joining point will be called a node. At each node, we're going to have some new trait that's going to come about. So everything that is after that node will have that trait. Okay? So we see here we have anchors and roots at this node, which means that everything after that will have anchors and roots. You see here we have flowers that came about. So all of these have flowers, but nothing before that will have flowers because that's a derived trait. Okay. There's a video. I'll post the PowerPoint on Schoology. You can watch this video. All right, the tree of life. Darwin suggested a tree of life. He takes it up where it's a branching with a original common ancestor, and then he starts with the domains coming out of it, and then after each domain he takes the kingdoms inside of those domains and he breaks them down further. There's a really great video that's on this. Please, please, please get onto Schoology and grab the PowerPoint and look at the video on this one. Is extremely explanatory, and you need the characteristics for each of the kingdoms for this. It will be on the test. All right, let's review the similarities and differences between species concept. We talked about Linnaeus and Aristotle's, the typological one, where it's just physical characteristics. We talked about biological species concept with the mating and reproducing, and we talked about the phylogenetic, which is taking into consideration the evolutionary history of it. Phylogeny, that was taking in the evolutionary characteristics for a species to break them up into species, and the cladograms are broken up after derived characteristics come about. All right, go to this site, take the quiz, and after this, you guys are going to need to do your activity. So, bye. See you guys on Friday.